Right, now when I say nasty quadratics, I mean quadratics with a coefficient of x squared, because they are that bit trickier, and there's more than one way to do it. Now this is a humdinger of a question, and it's just really, really good practice, because in so many A-level questions, you're going to need to factorize quadratics, which involve factors of x squared. So I'm going to do all of these. I'm going to do some of them more than one way, because there are different options whether or not you want to use the calculator, but you have to be careful with that anyway. So I'm going to start with the simplest ones, which have got to be the ones without the coefficient. So if I go for that again, hopefully we can all see that 8 times 4 is 32. The difference between 8 and 4 is 4, so it's going to be x and 8 and x and 4. We want it to be negative, so the larger value has to be negative, the other one is positive. Now if you wanted to do that just with the calculator, you could do that pretty quickly. You've just got to watch out for one thing. So we're going to polynomial, and the coefficient of x squared is 1, negative 4, and we've got negative 32 on the end. Now when I press execute on that, it gives me positive 8 and negative 4. That's because that's the solution of this, and for the solution you need the brackets to be worth 0, don't you? So it's going, if you use the calculator, you've got to change the polarity, swap it from negative to positive or positive to negative. Right, so if we do that for this one as well, it's 4 4s are 16 and 4 add 4 is 8, so you could do x plus 4 and put a squared on there, but just to make the cancelling easier, I'm going to put it there. Now straight away I can see that I can cancel the x plus 4 on the bottom and the x plus 4 on the top. Now often when you're simplifying algebraic equations, if it was just this one over this, I would know that x minus 8 is going to go into that, but it's probably going to go into 1 somewhere, but I'm not sure which. As I write this out now, I'm going to turn this division into a multiplication by writing it out again with the 10x squared on top, by doing a little stay change flip basically, aren't I? And 8x squared plus 20x, take 48 on the bottom. And those two are going to be from there. So I'm going to start looking at these now. Now if I was going to do this without a calculator, I would multiply the coefficient of A by the one for C. So 2 times negative 40 is negative 80. Now because it's a negative, that means this number is going to be this coefficient of x is going to be the difference between the two numbers that multiply to make 80. So I'm just going to use a different color here so we hopefully don't get too confused on it. So I'm going to look at my factors of 80, and I'm looking for the two numbers whose difference is negative 11. So the difference there is 79. The difference 2 times 40 is 38. 4 times 20, the difference is 16. 5 times 16, the difference is 11. So it's those two that I want. Now that I know that it's those two that I want, now I start another little process up. So I'm going to write out 2x squared, take 11x, take 40, which is what I've got there, and then I'm going to write that again as being 2x squared. Now to get negative 11, I'm going to need negative 16x and plus 5x, take 40. At this point, I split this expression into two slightly simpler expressions that I can then factorize with a single bracket. So my single bracket factorization, 2x goes into both of these, so that 2x is going to go outside the bracket, times x, and 2 times negative 8 to make 16. And that means that one of my factors, one of my brackets, is going to be x minus 8, so I pop that in just there. And what goes in 5 times x makes 5x, 5 times 8 makes 40, so that's correct, that's going to be positive. And that means that this is my other bracket, so it gives me 2x plus 5 and x minus 8. And that is going to go back up to here. So 2x plus 5 and x take 8. And that's nice because we've got an x take 8 on that one. So we've simplified that bit. Right, now, if we go back onto here, if we wanted to use the calculator to do this, we could have done. It doesn't always work, because sometimes if you don't get, it can be tricky if you don't get a whole number answer, but as long as you get at least one whole number answer, it can be useful. So right, so we've got 2 for our a, our number of x's is negative 11, and our constant is negative 40. Press again on that, and we get x is 8 and x is negative 2.5. So what I would do there is I would say I've got my 2x squared minus 11x take 40, and remembering that the bracket's got to equal 0, that means that I'm going to very likely, not totally certain, because that could be 2x minus 16 as a bracket, but it's quite rare. That means x minus 8 is going to be one of them. And once I know that x minus 8 is one of them, x time is going to need to be multiplied by 2x to get the 2x squared, and negative 8 times plus 5 makes negative 40. So that would give it to me there. But I would just need to double check that it all works by doing 5 times x is 5x, and negative 8 times 2x is negative 16x. That does equal minus 11x, which is what we wanted. So that means that has worked. So you can save yourself some hassle with the calculator, but you do need to be careful. So I don't know which one you'd rather do. Let's have another look at 6x squared minus 3x take 45. So we don't get too confused, let's go in red for this one all the way. So we're looking at 6 times negative 45 is 240 plus 30 minus 270. So we are looking at factors of 270 whose difference is just 3. So we're looking for numbers quite close to each other. So I could go through 1 and 270, but there's not that much point. I could say, right, I know 10 times 27, the difference is 17. So we're looking for a couple of factors that are closer together than that. But it might be tricky to find. So to give myself a bit more of a way in, I'm going to do a couple of these. So half of 270 is 135. 3 goes in 90 times. So now I'm thinking, right, 3 goes into 90. What big factors are there of 90? And I'm thinking 30 is 1. So 30 times 9. But that's obviously a bigger difference. But then what about half of 30? Half of 30 is 15, isn't it? Does 15 go in? It should do, couldn't it? Shouldn't it? Because 270, if 30 goes in, 15 will go in. How many 15s in 270? Well, it's going to be twice the number of 30. So it's 15 times 18. And I've found my 3 there. So that means I must be looking at 6x squared, take 18x plus 15x to make the minus 3x when they add together take 45. I then put a box round those like that and do my factorising of both of those, and I get 6x goes into both of those, doesn't it? So I know 6x is going to be one of my factors, and I get x take 3. So that means x take 3 should end up over here. What do we times x by to get 15x? It's 15, and 15 times 3 is 45, so that all works. So that means we're ending up with x take 3, 6x plus 15. If you want to do that in your calculator, you can do. It would give you a positive, it would say that x equals plus 3, and the other x, the other value is going to be a fraction. But from that, you could say, right, that's going to give me x minus 3, and you can just take the factor of that out of it, and that can help. So where does that go? That goes up here, doesn't it? So we've got x minus 3, 6x plus 15, and we can't simplify that with anything. Now I'm going to challenge you to have a go at using either or both of those methods to do this one here, and in a moment I will cut to what the answer of that is. So pause it, have a go at that, and then I'm going to cut straight to it. I'm not going to demonstrate those as well because it'll take forever. So if I clean this all up a bit, I've just got 2x plus 5 for that one, and that's being multiplied by x plus 4 on the top there, x take 3, and 6x plus 15, and then you should have got, for 10x squared take 45x plus 45, x take 3 for one bracket or one factor, and the other 10x take 15, and the one underneath you should have x plus 4, which is nice, and 8x take 12. Now we're trying to get towards a situation where we've just got one number over another, and I can cross out my x take 3's, but I've still got, if I write this, I've still got on the top 2x plus 5, 10x take 15, and on the bottom 6x plus 15 times 8x take 12. Now you might be a bit confused, think, oh, what do? I can't just move that on up to the top, but what you do is look to see, can any of these brackets, do they relate to each other? And oh, 2x times 3 is 6x, 5 times 3 is 15, so I could, there's one of those and 3 of those. So if I have a little look at how that can move on, that gives me 1 times 10x take 15, so 10x take 15 on the top, and 3 times 8x take 12. Now, can we do anything with 10x take 15? I could factorize that, couldn't I? 5 goes into 10x 2x times, and 3 times into 15, and then I've got 8x take 12 on the bottom like that. And having a little look at this, let's look at the brackets again. 2 times 4 is 8, so 2x times 4 is 8x. 3 times 4 is 12, so we could divide that exactly 4 times into that. So that's going to be 5 times 1. That's going to be 3 times 4, which gives me 5 over 12. So that was a real humdinger, wasn't it? And we got there in the end. Loads of working all over the place, and there would have been even more if I'd showed you how to do the 10x squared and the 8x squared. Let me know if you've got any more questions about any of that. I hope it helps.